Jai Hind everyone. My name is Vaishali Deshwal and currently I'm working as an assistant professor in Akgec, Ghaziabad. So today this is the third session on machine learning techniques and their code is KAI 601. So we are discussing the syllabus of machine learning as per AKTU. But in today's session we will discuss some major topics like regression and SVM. So first topic is regression. We'll see that what is regression, what are the different types of regression, and what is SVM, and what are the different kernels, what is the concept of kernel in SVM. So regression analysis is the statistical method to model the relationship between a dependent and independent variable. Means in this we are just going to find out the relationship between the dependent and independent variables. And it helps us to understand that how the value of the particular dependent variable is changing corresponding to an independent variable. Means on changing the independent variable, how the dependent variable is changing. So we have to find out that relationship, and that is all about regression. So it predicts the continuous and real values, for example, salary, prices, etc. Let's consider this example. So this example, it has two columns. First is advertisement, second is sales. So we are going to predict sales on the basis of advertisements. Suppose there is a marketing company named A who does various advertisement every year and gets sales on that. So the below list shows the advertisement made by the company in the last few years. So we have the advertisement, the prices which we are spending on advertisement, we have that particular data, and correspondingly we are going to predict the sales, that what will be the sale in that particular on that particular sale, on that particular investment on advertisement. Suppose we are having $90, so correspondingly the sales is this, then for 120 the sales is this, and so on. So advertisement is the independent variable and sales is the dependent variable, because it depends on, its value depends on the advertisement. Lastly, we have this $200, and correspondingly we have to find out that what will be the sale for this particular amount. And again you can see here, as we have discussed in this last point, that it predicts the continuous and the real values. So here also these are the continuous and the real values, these are not the categorical one. So now the company wants to do the advertisement of $200 in the year 2019 and wants to know the prediction about the sale for this year. That is the task, and that is the regression problem. So it helps in finding the correlation between the variables, the independent variable and the dependent variable, and enables us to predict the continuous output variables based on the one or more predictor variables. So it mainly used for prediction, forecasting, time series modeling, and determining causal effect relationship. Regression is all about a line, that in this we have to draw a line to predict the further values, the future values, depending on the dependent variable, independent variable. So regression shows a line or a curve that passes through all the data points on target predictor graph in such a way that the vertical distance between the data point and the regression line is minimum. So the goal is that we have to minimize this particular distance. So as you'll see in a graph, that how to minimize this particular distance, and what is this distance between the data points and the regression line. Suppose this is a regression line. Suppose this is a regression line and I have points here. Here we have points. Okay, so this distance, this is the vertical distance we are talking about, and the sum of this particular distance we have to minimize. Okay. So now there are several types of the regression, and in general we are just in syllabus, you can say, we will discuss linear regression and logistic regression as per the AKTU syllabus. So it is the first topic in unit 2. Types regression is all about that what are the types of regression, then what are the applications of it, etc. So there are various type of regressions which are used in data science and machine learning, and some important types are For example, linear regression is there, then we have polynomial, SVR, then decision tree regression, and random forest regression, ridge and lasso regression. So we'll discuss in detail this linear regression, logistic regression. Now let's start with linear regression. So linear regression is a statistical regression method which is used for predictive analysis. Okay, so in this also we have to just find out the relationship between the variables. One is the dependent variable and the independent variable. The independent variable, it can be 1, it can be 2, it can be more than 2. Okay, so the aim is to find out the relationship between the those variables. So it is used for solving the regression problems in machine learning, and linear regression shows the linear relationship. Linear means a straight line. You have to draw a straight line between the independent variable and the dependent variable. Okay, so generally we draw this independent variable as on x-axis, x-axis, and dependent variable on y-axis, and this is known as linear regression because in this we have to show a linear relationship, that is a straight line. So if there is only one input, then such type of the regression problem is known as simple linear regression. Okay, and if there is one more than one input variable, suppose I am having 2, 3 independent variables to predict a particular variable, so such type of the regressions is known as multiple linear regression. Okay, so the relationship between the variables in the linear regression model, it can be explained by this particular figure, by this particular image, you can say. So in this we are having experience, we are having two variables in this. Okay, first is the experience and second is the salary. So we are predicting, or we are interested in predicting the salary on the basis of experience. So as this graph shows that if a person is having 2 years of experience, then he is getting 40,000 as salary. If he is having 4 years of experience, then correspondingly he is getting 60,000 as salary. Okay, so this graph shows a linear, means this is straight line, you can say it shows a straight line between the dependent and the independent variables. So we have to draw this straight line so that for any particular value of the experience, correspondingly we will get the salary. Okay, suppose I'm having here I have a value like 20. Suppose a person is having 20 years of experience, so what would be the salary that he is getting? Okay, so here we have to predict the salary on the basis of the years of experience. So, and the goal is to make or draw a straight line. Now now what would be the equation of this? So there is some mathematics involved in linear regression, and this is the mathematical equation for linear regression. So let's understand it. Y is equal to ax plus c. What is y? Y is the dependent variable. So if we see in this figure, what is the dependent variable? It is salary, so y is salary. Then a is a and b, they are the coefficient, they are the linear coefficient, you can say, and x is the independent variable, or you can say the predictor variable. In this figure we have experience as the independent variable, so x is the independent variable. Okay, a and b are the linear coefficient, a is the slope and b is the intercept. Intercept is like this, so this is the intercept, and slope is that if there is 1 unit change in x, if there is 1 unit change in x, then what would be the change in y? So this is the slope. Okay, so a and b, they are the coefficient and they represent the slope, and b represent the intercept. There are some popular applications of this particular regression, and these are like we are having analyzing trends and sales estimates for sales forecasting, as we have seen an example of this. Then real estate prediction and arrivals at ETAs in traffic, and many more. Okay, so this is all about the linear regression. So next regression is logistic regressions. There are many questions related to this logistic regression. That logistic regression is used to solve classification problem. Then why we are saying that it's a regression? Okay, so logistic regression is the another supervised learning algorithm which is used to solve the classification problem. This is the main point, that it is used to solve the classification problem. Means in this the variables, they are to be categorical, like true false, like male female, means it should be in the categories, like yellow red is that. So in the classification problem we have dependent variable in binary and discrete format. For example, we have 0 or 1, means the variables, they should be in the categorical form. Now the logistic regression algorithm, it works with the categorical variable. Again, this we have studied, like 0 and 1, yes or no, true and false. And if we have to categorize a mail, that whether it should be in the spam category or non-spam category, then it is a predictive analysis algorithm which works on the concept of probability. Okay, so here we'll see some. Okay, so here we will see some mathematical intuition of logistic regression. So it is the type of regression, but it is different from the linear regression. And that is the reason why we are saying that the logistic regression is the regression, because the concept is same, but we are using here, here we are using sigmoid function. So it's a type of regression, but it is different from it in the term that how we are using it. Okay, so it uses sigmoid function, or you can say logistic function, which is a complex cost function. And what is it? So this is simply this function is y is equal to 1 by 1 plus e to the power minus x. So here fx is equal to the output. It can be 0, it can be 1, it can be true, it can be false, and x is that what is the input you are going to give to the function. E is the base to the natural algorithm. So this is a simple sigmoid function on which this logistic regression works. Now here, here this is a concept of logistic regression. So it uses a concept of threshold level, and it gives you, when we provide the input values or the data to the function, to the sigmoid function, then it gives the S-curve, and this is the S-curve as you can see here. So here we are having two categories, one is 0 and the other one is 1, and in middle we are having 0.5. Okay, so it uses a concept of this threshold, and the values above the threshold level, they are just rounded up to 1, and the values which are below the threshold level, this is a threshold level, so 0.5. If we are getting like 0.3, so it is rounded up to 0. Okay, and if we are getting 0.8, then it is rounded up to 1. So sigmoid function is a mathematical function which is used to map the predicted values to the probabilities. This is very important, that whatever the predicted values, sigmoid functions just map those values to the probabilities. It maps any real value. It can be 0.3, 0.8, it can be anything within the range of 0 or 1, because this is used for the classification purpose. Because we cannot use the linear regression for solving the classification problems. So next we are having some types of the logistic regression. So two concepts we have studied in logistic regression. First was the sigmoid function and the S-curve. Okay, then generally it means that the binary logistic regression having binary target variables, but there can be two more categories of the target variable that can be predicted by it. And we are just dividing the logistic regression on the basis of the number of categories. So it can be categorized into like binary or binomial, multinomial and ordinal. Okay, so first is the binary and binomial. What is binary? Binary means 2. So in such kind of the classification, and dependent variable will have only 2 possible values. It can be 1, 0, it can be true, false, it can be red, yellow, it can be anything, but we are having 2 possible types. For example, these variables may represent the success, or failure, yes or no, win or loss, etc. So just as the name suggests, binary, it should be stick to 2. Next we have multinomial, means in this the dependent variable, it can have 3 or more categories, but it should be unordered type, and that is the basic difference between the multinomial and the ordinal. So we should focus on this unordered types, okay, the types having no quantitative significance. For example, it's type A, type B and type C. Then we have ordinal. So in ordinal, in such kind of classification, the dependent variable can have 3 or more possible order types, other types having a quantitative significance. So again, you have to just focus on the ordered types. Okay, so for example, these variables, they may represent poor, good, very good, excellent. So there is an order. Okay, so this is a basic difference between the multinomial and the ordinal. Both can have the 3 or more possible values or more categories, you can say, but it is unordered type and it is the ordered type. This is the basic difference between now this is a basic difference between the linear regression and the logistic regression. So we'll discuss only few differences between the two. So first is that linear regression, it is used to predict the continuous dependent variables, okay, while the logistic regression, it is used to predict the categorical. So you have to remember this categorical and the continuous. Okay, now it is used to solve for the regression problem, means the real values will be there, and then here it is used for the classification problems. Here we have the continuous variables, here we will have the categorical variables. Okay, now in this we have to find out the best fit line, that straight line, and in this we have to find the S curve. Like we have to just divide each and everything between the two categories. It can be 0 or 1. If the threshold, and there will be a threshold value, if a particular value is above that threshold value, then that will be rounded up to 1. If it is below that, then that will be rounded up to 0. Okay, here for the estimation of the accuracy, linear regression uses least square estimation method, whereas logistic regression, for the estimation of the accuracy, it uses the maximum likelihood estimation. Okay, rest you will study. The main differences are that it is used for the categorical. In this we are having the categorical variables, and in this linear regression it is used to find out the best fit line. We are having the continuous variables, etc. Okay, so this is the EM algorithm, and it is very important in machine learning. EM, it stands for expectation and maximization. So it's an algorithm which considered a latent variable model to find the local maximum likelihood parameters of the statistical model, which are proposed by Arthur in 1977. Okay, so this algorithm is defined as the combination of the several unsupervised machine learning algorithm, which is used to determine this maximum likelihood estimates, or you can say maximum a posteriori estimates, which in short we can say MAP, for the unobservable variables. So EM works on the latent variables, and latent variables are nothing but the unobserved variables. Means the latent variables are those whose value depends on the others. These are the unobservable variables. So it is a technique to find out the maximum likelihood estimation when the latent variables are present. Okay, and algorithm, it consists of the two modes. First is expectation and second is maximization. So in the first mode, we estimate that the missing and the latent value variables, okay, the unobservable variables, you can say, whose values depend on the other variables, and we have to find out. So this is known as E step, or you can say expectation or estimation step. We have to estimate that what would be the missing value. Further, the second step is the maximization step. So the other mode is used to optimize the parameter of the models so that it can explain the data more clearly, and that is the maximization step, or the M step, you can say. So this is the simple diagram. Here EM algorithm, it involves the two steps. First is the E step. E means the estimation step. In this we have to update the variables again and again we have to find out the values or the missing values for the latent variables. And in the M step, again we have to update the hypothesis. So here we are updating the variables, here we are updating the hypothesis, and the EM algorithm depends on these two steps. Next is E step. So it involves the estimation, and M is that it involves the use of estimated data and updating the parameters. And we have to repeat E and M step until the convergence occurs. So we have to repeat until the convergence occurs. Now, what is convergence? Convergence is defined as a specific situation in probability based on intuition. Suppose there are two random variables we are having, and that have very less difference in their probability. So those two variables, they are known as converged. What are the steps in EM algorithms? So it mainly involves 4 steps, which is the initialization, E step, maximization, and convergence step. And as you can see in this particular diagram here, it is very much understood that from here you will start. Then this is the initialization. You will initialize the different values to the particular variables, to the different variables you can say. And then the expectation step, in this you will update the variables, and maximization step, in this you will update the hypothesis, and then we will check that whether the convergence occurs or not. If yes, then we'll stop. If not, then again we have to repeat this expectation step. So it is very simple. You can read the theory here. What can be the applications of EM algorithm? Application, the primary aim or the goal of EM algorithm is to estimate the missing data. It's all about the latent variables. The latent variables are the unobservable variables. Unobservable means that we cannot just directly extract the values of those variables. Their values we can extract from the other variables. So we have to estimate the missing data, and it is applicable in data clustering. So it is used, and the third application, the most important application, that it is used in NLP and computer vision. It is also applicable in medical and healthcare industry, and in image reconstruction and structural engineering. What are the advantages? That it is very easy to implement. It involves mainly it involves the 2 steps, E step and M step. In one we are just updating the variables, in the other one we are updating the hypothesis, and it is guaranteed most of the time that the likelihood will enhance after each iteration, and it often generates a solution for the M step also. What could be the disadvantages? So the convergence is very slow, and we have to stop when the convergence occurs. So the convergence is very slow. This is one disadvantage, and the other is that it can make convergence for the local optima only, not for the global one. So this is the another disadvantage of this. So I think this is the good point to stop here. So today in the session we have discussed that what is regression, what are the different types of regression, what is linear, what is logistic, and that is again very important. The differences between the two is very important, and after that we have discussed what is EM algorithm. So what is EM algorithm, what are the steps involved? Mainly it involves the 2 steps. What are the applications, what are the advantages, and what are the disadvantages? So in the next session we'll discuss that what is the SVM, what are the concept of decision boundary, what is hyperplane, what is maximum hyperplane, and how to choose that, and what is margin, etc., and many more topics. So